there's one last thing we need to fix with our report, and this is that last column. So notice that when average is computed, it ends up having different numbers of digits after the decimal place, right? Sometimes it has 3, sometimes 1, sometimes 2, and even in some cases, none at all. So those numbers look a little messier. They're not this fine, everything lined up report. Now, we could left justify this column. In fact, let's do that just to see what happens, because that lines them up in a different way. And we run that, and we might think, well, maybe this will line things up a little bit better. Oh, this is going to cause another report, another problem. When they get left justified, they do line up, but there's no space between them because we have a right justified field right next to a left justified field. So that's pretty messy. And the other thing is it works out fine till you get to something like 11, where, again, we have to deal with this 2 digits versus 1 digit. And in this case, 11 has 2 digits, and so things don't line up too nicely. So we can actually see this. I'm going to put a space in here. Now, so we can combine IOManip with just spaces as well. So here I've just added 2 spaces before this field. If I added the spaces after the field, it would put the spaces in the field, and that's not what we want. Okay, we'll slide it over and then we'll be able to see what I'm talking about. Okay, so now we added those spaces and then we created this last field and we left justified it. So now notice these numbers are lined up nicely right until you get to something that's 2 digits long. And now that decimal place is offset. So really with numbers, we do still want to write justify, but we also want to have the same number of digits. So if we want everything to line up, we write justify them and then we put the same number of digits after the decimal place. So let's go back to right, and we can get rid of the left and the space, and because it'll stay right? We set it right, and we just want to leave all of our numbers right, and we'll go back to left when we get to the names. So we can leave that one the way it is, because that will work how we want it. But now we need to figure out how to just get 2 digits after the decimal place. This is something that we can do with IOManip. IOManip has some really nice formatting options for us. And so we're going to use 2 functions for this. And these are functions that once you set, they stay set. And we are going to just want to set it one time because we want all of our numbers to be this way. And we won't have to worry about setting it again. So I'm going to actually do this outside the loop. And now these changes, IOManip, apply to a specific file stream. And so we have to say which file stream do we want it to apply to. And here we're using the out_report file stream, right? And so we use out_report and we use the insertion operator to where we want to set this. One of the functions we want is setPrecision. And setPrecision, when we tell it, by itself, when we just want setPrecision, so let's say I set it to 4, this is going to say how many significant digits to display. So let's see what this does. And what it does is it does a maximum, it does up 4 significant digits, or up to that if it doesn't have any more. So in this case, where it has a 6.375, that's actually 5 significant digits, right? I mean, four significant digits, and so it's showing that. And here, 11.62 is also 4 significant digits. Now remember, this one had a 5 on the end, but the leftmost one is more significant. So if it has to drop one, it drops one on the right. So 11.62. So it's showing how many significant digits. Here, this one has 5. Now what about the 825? Well, there wasn't any more significant digits to print. Zeros after the decimal place are not significant. So even on the 1, it doesn't show any. So we're getting 4 significant digits if there are that many. If there aren't that many, then it just gives you however many you need to give all the information about the number. Now notice here, it did give us a 0 before the digit, before the decimal place, to show us that that significant digit was 0. So this is not quite what we want, because setPrecision by itself gives us significant digits. And what we really want is the number of digits after the decimal place. So to get that, we have to set another flag. And this one is fixed. So there are different kinds of numbers that can be formatted. And the formatting we want is fixed point notation. And the way we get that is with fixed. Another one is scientific. If you want scientific notation, which is the numbers raised to times 10 raised to a certain number. Use that for big numbers. But what we want is we want fixed point notation. So we set the flag fixed. Now set precision works different. So now what set precision is going to do, let's run this, is it's going to say if you're using fixed point notation, then when you set precision, it identifies how many digits after the decimal place. And so when we say 4, then we get 4 digits after the decimal place. Now notice how all of our numbers line up, because no matter how many are to the left, it doesn't matter because we've got it right justified and we have 4 decimals after the digit place. So now we have them lined up. Now we have to decide how much information do we want, how many details on average. So let's say that we just want, we can choose. Do we want 3 digits after the decimal place? Do we want 2? Do we want 1? Let's go ahead and let's do 2 and see what happens. And then go back and look at our report. And now it's going to give us, since we're using fixed points, it's going to give us 2 digits after the decimal place. Now I want you to notice something here about how it displays these numbers. So this was 6.375. Well, now notice that 7 has changed to 8. We dropped the 5 because we're not showing that many digits after the decimal place. But why did it change the 7 to an 8? And that is because when it isn't going to display a number, it will round it. So it gets as close to that as it can. Now, why didn't it do it on the 0.125? This would be an indication that that computation was slightly under 5, right? If it's 5 or greater, it will round up. If it's less than 5, and it can be less than 5 by just a teeny bit, if it's less than 5, then it will round down. And so we're seeing both things happening. We're seeing it round up in some cases, we're seeing it round down in some cases, and that would be a result of the computation itself. Now, another thing to note is it is not changing the numbers that are stored here. So what we're printing out is we're printing out this average, and it isn't actually changing the value of average. It's only displaying it a certain way. So it's really formatting the output. And when it does that, it rounds to the nearest number using the number of digits that we can set it to. So let's go ahead and set it to just 1, as we don't need very much accuracy here. And this just really would depend on the particular problem, right? How much precision do you want to show? And you can just show whatever precision you want. So let's show 1 digit of precision. That's 1 digit after the decimal place. And see how our report looks now. So now we have the name, the town, the number of minutes in the commute, the number of miles in the commute, and the average minutes per mile in the commute. So there's our report. Look at that, everything lines up nicely. We're able to print out all of the values, and we lined things up the way we wanted and made decisions about the numbers, how we wanted those numbers to display when they were output. So that's what IO-manip will do for us. And by the way, you can use IO-manip on cout, right? Cout is an output stream, and you can line things up when you're printing things to the console. So you can use it with cout, or you can use it with an OF stream object that you're working with.